Hello, geometry. This is Miss Doolittle, and I wanted to make as quick as I can, at least, a quick video on parallel lines cut by a transversal. Now, that being said about being quick, that's difficult for me because I tend to talk a lot and over-explain sometimes. So I am going to purposefully try to make this as efficient as possible. If there is any point in time when you need to pause the video so you can jot a couple things down, please feel free to do so. But I'm going to try to go through the material as quickly as possible out of respect for your time. Okay, so let's go ahead and get started. So we're talking today about parallel lines that are cut by a transversal. Obviously what we mean here is that this top line and this bottom line are my parallel lines. This line running at a diagonal that's intersecting both of those is referred to as the transversal. Okay, so when you have parallel lines cut by a transversal, this should all be review material for you guys, by the way. I believe it was in first semester, or possibly even in the past when you guys learned about this, but so I'm hoping that this brings some memories back here. We have certain angle relationships that we need to talk about. First off, we are going to hit all of the angle relationships that result in congruent angles. Okay, congruent, of course, means that they have the same measure. So if we start with angle 1, okay, going to take a look at angle 1 here. And what vertical angles mean, we're going to start with that relationship of vertical angles. Obviously, those are going to be congruent. Vertical angles are angles that share a common vertex. They do not share a common side, only a common vertex. So if we look at this first group of angles here created in this top intersection point, are created by that top intersection point, we're going to see that angles 1 and 4 are the only angles that share a common vertex, but not a common side. Okay, they're kind of across from one another. To help me back in the day remember vertical angles, of course it starts with the V. I thought about the angles themselves as being V's facing in opposite directions, but the points of the V's were touching, right? That was that shared vertex. Okay, so vertical angles, I can say at this point now that angle 1 is congruent to angle 4. I could also state this as angles 1 and angle 4 are congruent. Angles 1 and 4 are congruent. Okay. All right. Now let's take a look at a different angle, not angle relationship, but a different set of angles. So I can look at angle 2 and you can see the angle that with angle 2 that shares a vertex but not a common side is angle 3. Okay. So angles 2 and 3 are also vertical angles. And that means angles 2 and 3 are congruent. All right. Okay, now, obviously you're going to be able to look down below and see that there's all kinds of, there's a couple other vertical angle relationships from that bottom intersection point. But before we get to that, I want to jump to corresponding angles. It's a different definition, so it's a different angle relationship that we're going to be talking about. Although the result of that angle relationship is the same, corresponding angles are also congruent to one another. And I want you to picture this. If I could take this top line and literally scoot it down, pick it up and move it so that it's literally physically resting on top of the bottom line, then angles 1 and angle 5 would be in the same location. Okay, so we're talking about angles that are in the same location but with a different intersection point. Okay, so you can see that 1 and 5, you could refer to them as kind of like they match up, right? They're in the same position, just in the different with the different intersection points. So what that means is I can say that angles 1 and 5 are corresponding angles. I can also say then that angle 1 is congruent to angle 5. All right, now we can obviously continue that whole thing all the way through this. I can say that angle 2 is in the same position as angle 6. So that means angles 2 and angle 6 are corresponding, therefore they are congruent angles. And I can do the same thing with angle 3 and angle 7. So angle 3 is in the same position with that top intersection point as angle 7 is with the bottom intersection point. Therefore, angle 3 and angle 7 are corresponding angles, but they are actually also congruent. We can say that angle 3 is congruent to angle 7. And then, obviously this last one, angle 4 is in the same position as angle 8, just with different intersection points. Therefore, angles 4 and 8 are corresponding, and angles 4 and 8 are congruent. Okay, now that we have gotten that out of the way, we've talked about all of our corresponding angles and we've matched them all up. And so now we can take a look at this and see that angle 5 and angle 8, that also fits the definition for vertical angles that we just talked about. So I can say that angle 5 is congruent to angle 8. And you can see that even through this thing that we did with our corresponding angles, sure enough, it turns out since they're in the same color, right, the way that we went about this, that means 5 and 8 are also congruent. They are vertical and they are congruent. I can say the same thing for angles 6 and 7. So angle 6 is vertical with angle 7, and therefore they are congruent. Angles for you. We are still talking about congruent angles. Okay, and we are going to apply we're going to apply some different angle relationships for these congruent angles. So this part is kind of definitional. We can see all of my purple highlighted ones are the same angle measure, and all of my blue highlighted ones are the same angle measure. But we've got some definitions here that we need to work out. So first type of other angle relationship that we're going to refer to are alternate interior angles. Okay, now the first thing I need you to understand about the word alternate in this type of a case, that means on alternate or opposite sides of the transversal. Okay, to help us with this idea of interior and exterior, I put a couple words in here so you could see. So interior is going to be anything inside those two parallel lines, in between the parallel lines. The exterior is going to be on the outside of those parallel lines. Again, if you need a kind of a real world example of those, think about the interior of your home versus the exterior of your home, and that can help with that. So alternate interior angles, here we go. Alternate means on opposite sides of the transversal, and interior means on the inside. So let's start with angle number 3. So angle number 3 is over here on the left side of the transversal, and it's on the inside of the parallel lines. So what we want to do is go over here to the right side now of the transversal, and still remain in the interior of the parallel lines, and we're going to end up with angle 6. So that means angles 3 and 6 are alternate interior angles, and what I want you to remember is that alternate interior angles are always the same angle measure. They're congruent. Okay? See if you can pick out the other pair of alternate interior angles. Okay, hopefully you got that angles 4 and 5 are the other set of alternate interior angles. They are on alternate or opposite sides of the transversal, and they are located in the interior of my parallel lines. Okay, now we're going to talk about alternate exterior angles. Alternate having the same meaning of opposite sides of the transversal, exterior being on the outside of the parallel lines. So let's start with angle 1, because it is in fact on the outside or the exterior of my parallel lines. Okay, so now to find its alternate exterior angle, let's jump to the opposite side of the transversal and go to the outside on the bottom now of the parallel lines, and we end up with angle 8. So that means angle 1 and angle 8 are congruent because they are alternate exterior angles. See if you can find the other pair of alternate exterior angles. And hopefully you came up with angle 2 and angle 7. So angle 2 is congruent to angle 7 because those are alternate exterior angles. Okay, we are switching gears now. Instead of talking about angle relationships that result in congruent angles, Now we are going to be talking about angle relationships that result in supplementary angles. Supplementary angles add to 180 degrees. That is the definition of a supplementary angle. Okay. Now, within this diagram, we have all kinds of what we call linear pairs. And what a linear pair is, it is adjacent angles. Adjacent meaning adjoining, so they share a common side. Okay, so adjacent angles that together form a straight line. Okay, so if you think about that definition and you look at angles 1 and 2, you are going to see that angles 1 and 2 form a linear pair. So that means angle 1 plus angle 2 equals 180 degrees. I could go all over the place with this. Angle 1 and angle 3 are also supplementary, so they add up to 180 degrees. Angle 2 and angle 4 are a linear pair. And angles 3 and 4 are a linear pair. Okay, and I think we've exhausted all the possibilities now for this top intersection point, and we could go through and do make very similar statements for all of the angles in the bottom intersection point. So I'm not going to write that on the slide, but if you would like to jot that down on your notes, go ahead and pause the video now. Okay, now the other types of angles that we're going to see from this diagram are called same side interior angles. Again, we remember that interior is on the inside of the parallel lines. Exterior is on the outside of the parallel lines. Okay, and we've put those words in there for you so you can see that again, that the interior is the inside. The exterior is going to be the outside of those parallel lines. Okay, obviously same side, when we're talking about interior angles, that means on the same side of the transversal. Okay, so what we see here is that angle 4 most definitely, angles 4 and 6 are most definitely on the same side of the transversal, and angles 4 and 6 are both on the interior of our parallel lines. So we know then that they are going to be supplementary. In other words, angle 4 plus angle 6 is equal to 180 degrees. So there is one more pair of same side interior angles within the diagram. See if you can find that and write that down in your notes. Go ahead and press pause now. Okay, and hopefully you got that angle 3 and angle 5 is the other pair of same side interior angles. Therefore, they add up to be 180 degrees. They are supplementary. Now, let's do same side exterior angles. Again, same side of the transversal, but on the outsides of the parallel lines. So you can push pause now and see if you can come up with both sets of the same side exterior angles, and then we'll check when you get back. Okay, and hopefully you got that angle 2 and angle 8 are same side exterior angles, therefore they add up to be 180, and then angle 1 plus angle 7 are same side exterior angles, therefore they add up to be 180 degrees. And that's it, guys. So if you have any questions, please feel free to reach out and let me know. Thank you for watching.